Okay, we're talking about section 3.2 now. And the idea behind section 3.2 is we're going to find formulas for the derivative of a product of two functions, fg, and a quotient, f over g. Now, please be careful. Caution. You may think that the derivative of a product is the product of the derivatives. Why would you think that? It might be natural to think that because the limit of the product is the product of the limits. But this is not true. Okay, this is why we have to be really careful. This is why we're going to actually go through a little proof of the formula for this derivative, just so you can see why this derivative is not just the product. Okay, similarly, you might think that the derivative of a quotient would just be the quotient of the derivatives. And why would you think that? You might think that because, again, the limit of the quotient was the quotient of the limits. But again, that's not going to be the case. Okay? And so this is my caution. Be careful when you're thinking about the derivative of the product and the derivative of the quotient. This is the topic of section 3.2. We're going to derive special formulas for these two derivatives. Okay, so enough of the warnings. Let's get down into it. Suppose that capital F of x is equal to small f of x times small g of x. Then what is the derivative of this? F prime of x, by definition, is the limit as h goes to 0 of f of x plus h, g of x plus h, minus f of x times g of x over h. Good. So far everything is looking fine. Okay, so the problem here is that I've got a mixture of x plus h and a mixture of x in here. What I want to do is I'm going to have a little algebra trick, and I'm going to add and subtract the same thing in the numerator. And the thing that I'm going to add and subtract is going to be something I can use to factor out the right thing. So here I'll have my f of x plus h, g of x plus h, minus something plus something minus f of x, g of x, all divided by h. And now what should I add and subtract here? Maybe an f of x plus h times g of x. Will that work? You know what, let's do the f of x plus h first. So let's go ahead and take f of x plus h here times g of x, with the thought being that I have a similar term here. I'm going to be able to factor something out. Okay, similar to here. I've got to add, if I'm subtracting this, I need to add it back in. And notice now that there's a g of x that you're going to be able to factor out. And in fact, because I know what my formula should look like at the end, I'm going to group these two together and put that in the front. Now I'm going to factor out the g of x, right? So that's going to be f of x plus, that's going to be f of x plus h minus f of x, all times g of x divided by h. I'll put that there as a suggestion, so it's kind of suggestive, right? And then this one I'm going to put over here because I'm looking for a specific formula at the end here. And so here I'm going to factor out the f of x plus h, and then I'll be left with g of x plus h minus g of x divided by h. Good. And now here we go. You'll notice that this looks a lot like the derivative, right? G of x is independent of h, so the product here is just going to be g of x. So it's Let's see, what's that limit going to be? I think that's going to be f prime of x times g of x, right? And then I'll bring the limit in here as well. And so I'm going to assume that f is going to be continuous, so that I can go ahead and bring h in. And so that would give me an f of x times, here's the derivative of g. Good. There we go. And so, conclusion. The derivative of a product is f prime g plus fg prime, and this is called the product rule. The product rule. So this is kind of an abbreviation, right? I've left off my x's. Okay. So how would you use the product rule? Let's see. Let's see, do I have space here? Let's do a quick example before we go on to the quotient rule. So suppose I want to differentiate x squared times e to the x. Okay, so the rule is take the derivative of the first, which would be 2x, times the second, e to the x, plus the first, which is x squared, times the derivative of the second, which is e to the x. So there is my derivative. Good. Okay, we're going to get more complicated things than that in just a second. But let's move over to the quotient rule. And then the quotient rule won't be that. Quotient rule is the one for the division there, right? And then at the end of this video, there's going to be like a drill and practice kind of thing where you'll be able to take lots of derivatives using the product and quotient. All right, so let's take a look at the quotient rule now. What is the quotient rule? Let f of x be equal to f divided by g of x, which you could just write as f of x divided by g of x. Okay. Now let's see if we can write our derivative is the limit as h goes to 0 of f of x plus h over g of x plus h minus our f of x over g of x all divided by h. Good. Now this looks like a couple of problems from the exam, right? Okay, careful. Relax. It's okay. Let's just take it one step at a time here. I'm going to go ahead and bring this h over 1 up, right, as a 1 over h, just to get it out of the way for now. And then I'm going to rewrite this as a single fraction. And so to rewrite that as a single fraction, I'm going to need a common denominator. So the common denominator is g of x times g of x plus h, right? So the first expression is g of x over g of x, right? So that'll be f of x plus h times g of x minus, this one I'm going to take g of x plus h over g of x plus h, right? Well, I guess I should put f of x first. Oh well, I'll do that next. Good. All right. And now, in order to figure out what's happening here, I'm going to use the same trick that I had before. And that trick was to add and subtract some quantity in the numerator so that things work out. So the thing I'm going to add and subtract in here is going to be f of x times g of x. So I'll subtract it first and then I'll add it. Okay, so then I'll have the limit as h goes to 0 of f of x plus h g of x minus f of x g of x plus f of x times g of x minus f of x times g of x plus h. I'm just rewriting this stuff, right? That's all over, oops, I have my 1 over h over here. G of x times g of x plus h. Good. I think we're just about ready to go here. I'm going to go ahead and bring my g of x times g of x plus h out. And then I'm going to just rearrange things a little bit. And you might see here, we have a common g of x term. So that's going to be f of x plus h minus f of x. I'm going to go ahead and bring in my h times g of x, right? I notice I'm going to have some trouble with my derivative here, so I'm going to go ahead and put a negative sign there so that this comes first, and then I'll have g of x plus h minus g of x over h times f of x, right? So let's double check that. So the minus g of x f of x becomes plus f of x g of x minus g of x plus h f of x. It's right there. Good. And then this is all still all over g of x times g of x plus h. Good. And now you see where this is coming, where we're heading with this, right? So now when I bring the limit inside, all the limits exist separately, and boom, 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 boom. There we go. That's the quotient rule. So what does the quotient rule say? To differentiate f divided by g, take the numerator, take the derivative, multiply by the denominator, minus the top times the derivative of the bottom, divided by the bottom squared. I think there's a little song that goes with that, but you're going to have to ask somebody about that. I don't know any songs. Okay, so what I really want to emphasize here before we go is that the product rule now is the derivative of the product is f prime g plus fg prime. The derivative of the quotient, this is the quotient rule. Notice the order of things. This is still going to be f prime g, but now we take minus fg prime and then divide by g squared. So notice the similarity between these. F prime g plus fg prime, and this is f prime g minus fg prime divided by g squared. Okay, let's see, maybe we can do one more example before we go. Example, how about f of x equals x squared plus 1 divided by 3x minus 5. Okay, so then one way you could think about it, right, is just ignore this f of x, right? Let's just take this as f of x over g of x. This might be useful if you're just starting off, because your f of x is x squared plus 1, your g of x is 3x minus 5, and so your f prime is going to be 2x, and your g prime is going to be 3, right? And so the rule will be f prime times g minus f times g prime divided by g squared. So now you just have to put these pieces together. So again, the f prime g minus fg prime divided by g squared is going to be our overall derivative. So that's 2x times 3x minus 5 minus x squared plus 1. I'll go ahead and put this in order, right? So it's in normal order, divided by g squared, which is 3x minus 5 squared. Okay, so just one other quick note here before we go. If we're just writing down the derivatives, I'm going to allow you to write down the derivative unsimplified, so you can just leave your answer in that form, because I want you to think about being fast with just writing down the formulas. And then later on, some of the harder or the longer problems in the book, we can go ahead and we'll have to simplify those, okay? But the initial ones, like in the next video, I'm going to let you not simplify, just get the formulas down. Okay, so the next video, the drill practice for section 3.2, will help you remember the two formulas. Okay, try it out, and I'll see you later.